Now that we understand what a growth annuity is and that it's formed by making these equal periodic payments, if we want to calculate the future value, it would be very helpful if we had a more efficient way of doing it. Remember, the way that we did it was we took the future value of each of the 5 deposits. So here was the last deposit. The 4th deposit, or the second to last deposit, its growth was calculated by this expression. We had to add it to the value of the 3rd deposit, which we calculated by this expression. Oh, excuse me, that should be an exponent of 2, right? Because the 3rd deposit is going to get interest just for 2 years. Then we had the 2nd deposit. Its growth could be calculated by this, and the very first deposit's growth could be calculated by this. So this is just straight from the table in the previous video. And if we took the value of each of these 5 deposits, calculated them separately, and then put it together, we'd get the future value of the annuity overall. But again, that's terribly inefficient, because if this, even this alone, if it went on annually for 10 years, we'd have 10 separate calculations. So let's see what we can do to come up with a nice, concise formula. First things first, you might wonder why I'm going to do this, but if you remember from algebra, as long as what I do to one side I do to the other, then the equation will stay balanced. So what I'm going to choose to do is multiply everything through by 1.07. So on the left-hand side, I get A times 1.07. Now on the right-hand side, if I take 1,000 times 1.07, this is the new expression I would get. And I'm not going to simplify it, because I'm going to have some nice things happening in just a few minutes. I now have to take every expression, right? Not just the first one, not just this. I have to multiply everything by 1.07. So this next expression here, okay, when I multiply that by 1.07, it increases the exponent to 2. Multiplying this by 1.07 increases the exponent to the 3rd power. Multiplying this by 1.07 gives me an extra factor, so it increases it to the 4th power. And finally, our final, because it already had 4 factors, it now has 5 factors. Okay? So this is what we're looking at now. Now again, remember in algebra, as long as what I do to one side of the equation I do to the other, everything stays balanced. So now what I'm going to do is subtract this entire top equation from this new equation that I created. In other words, I am going to subtract, and I'll just rewrite it here, this whole thing. Now again, you might be wondering why I'm doing this, but let's just take a look at what happens. I'm going to get some nice things to start to happen, and things are going to clean up really quick here. Okay, so remember, what happens when you subtract like amounts? In other words, if you take 5 and subtract 5 away from it, you get nothing. If you take 10 minus 10, they cancel each other out. We're going to see the same thing start to happen here. First of all, on the left-hand side, when I subtract this top, the left-hand side, so I have A times 1.07 minus A. That's not where the fun things start happening. We start seeing some nice things happening on the right-hand side. Check out this expression. I am going to take away that like expression. They cancel out. Same thing happens with the squares, the cubes, and the 4th power. So really, all I have left from the top is 1,000 times 1.07 to the 5th, and from it, I'm going to subtract what I had left on the bottom, which is 1,000. Now we're going to start cleaning some stuff up. On the left-hand side, since I see an A in both terms, I can factor it out, and I have 1.07, and here is minus 1. On the right-hand side, I can factor out 1,000, and I have 1.07 to the 5th, and here I'll be left with a minus 1. Now, you might have forgotten what we were doing, or perhaps you weren't even sure what we were doing from the beginning. But our whole goal is to figure out a faster way to calculate A, our future value. In other words, what we're trying to do is get A by itself. So I am 2 steps away from doing that. First, let me just clean up the parentheses here. I'm left with 0.07. And then my final step to getting A by itself is to divide by 0.07. So what we're looking at is A equals 1,000 times 1.07 to the 5th minus 1 all over 0.07. You might not realize it, but what you're looking at right there is the formula for future value of growth annuities. It just happens to have our specific numbers plugged in for this example. So what we're going to do is backtrack. We're going to figure out what each of these variables stand for, or excuse me, what each of these numbers are in general, and replace them with a variable. 1,000. In this example, 1,000 was our periodic payment, or our periodic deposit. Now up until this point, we have not dealt with periodic deposits before. So new idea gets a new variable. We're going to call it R. Okay. The next number we encounter is the 1.07. Now 1.07 came from taking 1 plus 0.07. The 1 is just the 1, but think about the 0.07. The 0.07 is our periodic rate, right? When we're dealing with compounding interest, we have to take our interest rate, little r, and divide it by the number of compounding cycles in a year. Well, fortunately in this case our m was just 1, so it made things a little bit easier. Okay. Let's see, 5 is the next thing we encounter. Okay. 5 was the total number of transactions. So that's our total transactions. We already have a variable that stands for the total number of transactions, n. And then in the bottom, that 0.07, well, that's just our periodic rate again. So here's what we're going to do. We're going to replace every number up here with the variable that stands for it, and we will get our formula. So A equals, all right, 1,000, we will replace with R. So here's R. Okay. Now I have to take the 1 plus 0.07. Excuse me. 1 plus 0.07. Well, 0.07 came from R over M. And that gets raised to the nth power. Then we minus 1. Okay. All over, well, 0.07 was simply R over M. This right here, right there, is your formula for future value of growth annuities. If you look at your formula packet, it is formula number 24, and we will be using this formula and the formula above it in class when we start to work examples.